welcome Chris.
Thank you, Ryan. So at bioMerieux, I'm currently the technical lead and architect for several Angular web applications. And over the past year, we've been working to convert those over to using ngrx for our state management. And that's been really beneficial. We found it easier to kind of manage the complexity of our applications and to respond more quickly to the frequent requirements changes that we get. Last month, my friend Lance Finney presented here a talk called Beyond the Tour of Heroes, where he took the very basic tutorial from the Angular website, and he added some more advanced features, made it more kind of production ready. A few of the things he did was switch to on-push change detection and to using ngrx. So today I'm going to take the work that he did and keep going a little bit further. Specifically, we're going to be talking about adding immutability to our objects and using a new library called ngrx-enums, which just happens to be written by Lance Finney. The demo app for this talk is available on my GitHub repo. I'm looking at the right slide. You guys aren't. Okay. Sorry. There we go. Here's the link at the bottom for the demo app on my GitHub repo. Okay. First, I'm going to do a little bit of review on ngrx in case anyone missed last month's presentation. And for anyone watching this on the video, I do recommend you go back and watch Lance's presentation first. And the link is here on the previous slide. Okay. So specifically, we're talking about the ngrx store and effects modules today. And I like the way Victor Savkin described ngrx in one of his blog posts. He described it as a messaging system plus a central data store. And I like to think of it that way, where all of your actions are just messages in your application. So everything communicates through actions. Your actions can represent event notifications or commands, or they can be packets of data being sent off to update your central data store. So in an ngrx application, you have Angular components and services, and those should never mutate any state. Okay? They never mutate the state. If they want to affect a change in the central data store, then they need to dispatch an action containing whatever data is necessary, and then down the line, a reducer will do the business of actually updating the store. So it's very important that your components and services never mutate any state. And then they also subscribe to observables, which represent slices of data from that central data store. So the components that ngrx adds, again, are the action, which is really just a message with a type, which is a string, and an optional payload of data. And then we have the reducer. Again, the reducer is the only place where you are allowed to update the central data store. It is a pure function, meaning that it takes two inputs, the current state and an action. And from only those two inputs, it must calculate any new state and return that new state. And again, that new state is always a new object. We are still never mutating any existing objects. And then the last piece is an effect. An effect is really just an Angular service. It's fully injectable. You can make requests to the back end. You can do whatever you need to. You can look at environment variables, things like that. The effects API provides an actions object to you. And the actions object really is just kind of like a message bus. It's an observable of action objects. And in your effects class, you can react to those actions any way you want. The common pattern is, of course, to listen to actions and then dispatch new actions. So, for example, a component can say, I want to save this object to my back end. An effect can take that object, do the save on the back end, and then when the save is finished, can return a success action. That's sort of a typical usage of an effect. Okay, so here on the next slide, at the top I have a link to a really great blog post by Victor, where he really breaks it down and kind of uses some traditional messaging patterns to look at ngrx and the different types of effects and actions that you can have. And it's a short article, and it's really good. I have a couple links directly to some of his images, so I was going to bring that up real quick. So here we have it in pictures. So on the left, we have an Angular component, and whenever it wants to affect the data store, it's going to issue an action, or dispatch an action, which goes to our store. And again, this is Victor's diagram. He's kind of grouping all the effects and reducers together under the umbrella of store. And so we have several types of effects. He breaks them out into effects that decide between different actions, and effects that transform actions into new actions, and then general side effects like updating a database on the back end. So an action can optionally go through a bunch of effects, and they can also be handled by a reducer. And again, the reducer is where we actually update the central data store with that new data. And then any changes made to the central data store are going to propagate down to our component, who is listening to that observable of the data. Okay. So let's look at our app real quick here. So I'm going to start with the app where Lance left off last month. Just getting a quick review. This is a tour of Hiro's app. It's pretty simple. On our dashboard, we have 4 of our heroes. If we click on one, we can edit that hero. So I can type in a new name. See, it's updating there. If I hit back, it doesn't get updated. If I type in something and hit save, it does get updated. And we're going to see in a minute how easy it is to break that behavior. Okay. And just looking at the code real quick. So I will make this bigger. Okay. Okay. So just looking real quick at the state in our application. There we go. So all of our application state is defined in this interface called app state, which is broken into 2 sections. We have hero state and hero list state. So this heroes list is a list of all the heroes in our application. This should mirror the backend database. And then the hero property here contains which hero is currently selected and an additional Boolean flag for are we in the middle of adding a new hero or not. And so for these 2 pieces of state, we have 2 reducers, the hero reducer and the hero list reducer. And one of them real quick. So typically a reducer, again, it just takes in the current state and an action, and usually has a giant switch statement based on the action type. And then it always returns a brand new object when it wants to make any sort of modification. And in this example, we're using the object spread operator from TypeScript. Okay, and I'll get in a little bit more detail later on when we replace this with some ngrx-enums code. Okay. Just get out of here for a second. So we have a reducer. We also have an effect. So in this application, we have one effect called Hero List Effects. Again, it's just an Angular service, as you can see by the injectable annotation on the top. And all of these effects, they listen to actions dollar, which again is just an observable of all the actions in the system. And the next line, we're going to filter those by the type of the action. And then this one doesn't have a payload. If we go down to one that has payload, so typically you have your first line where you're subscribing to actions dollar, filtering it by the type of action, and then usually you're mapping the payload out so you can deal with it. Okay. So again, that was just intended to be a real quick review. Going back to the slides here. So now we're going to talk about immutability. Again, one of the basic tenets of ngrx is that these objects in your data store never get mutated, but ngrx doesn't actually enforce that your objects themselves are truly immutable. Okay, so if you just use ngrx by itself and start creating JavaScript objects and putting them in there, you're really just relying on your developers to never mutate anything. There's nothing there stopping you from mutating the state in your data store. So we're going to talk about how do we get true immutable objects. And there's 2 ways to achieve this. You can have compile time immutability. So there, of course, we're talking about TypeScript. and you can have runtime immutability with Immutable Jas. And ideally, we'd like to combine these two things together and get full compile time and runtime immutability. So why do we need true immutability? For one thing, we need it for ngrx. We also need it for on-push change detection to work. So when you change your component to on-push, Angular is looking to see if your inputs have changed before it redraws the view. And when it does that, it's not doing a deep comparison of the previous object and the new object. It's really looking to see, is this a different object instance than the one before? So if you're accidentally mutating properties on an object, your views are not going to be updated because Angular is not going to notice that you changed something. And so it's really easy, if your objects aren't truly immutable, to introduce subtle bugs and accidental data modification as well. So if you have mutable objects, then you're relying on the developer to make defensive copies everywhere that's needed and things like that. And that's really easy to forget. And so we're going to demonstrate that in our tour here, the app here. Presenter mode for just a minute. And just like Lance, I'm going to be kind of stepping through some GitHub commits here. So, just move up in here. Okay. So now I actually have a bug. If we open up the Hiro detail component, I'll make this bigger. Okay. And ignore the red line. WebStorm just hasn't caught up with my file switching here. So I've introduced another subcomponent here within my detail view. So if we look at the app real quick. Okay, so when we're editing, as we're typing, So the way I have it right now, as we're typing, it no longer updates the information above. It was before. So what I've done is this part that says Bombasto details is now in a separate Angular component that has on-push change detection. So as I'm changing this value here, Angular doesn't notice that the Hiro object is actually being updated. So let me go back for a second. I actually intended to do this backwards, but it's okay. Okay. And that's because I'm passing my Hiro object to the myHeroName component, and it's using on-push change detection. If I take this out and go back to traditional change detection, okay. Now as I type, it's automatically updating. So it really illustrates the difference between traditional change detection, immutable objects, versus on-push change detection, where they must be immutable and all changes must result in a new object. Okay. But the other thing I want to illustrate is an actual bug. So right now, if I hit back, Bombasto is fine, he didn't get updated, and that's good. But it's really easy to break that behavior. Okay. So, let me just go this for a second. Okay. So this is my Hiro detail view component. It's the component that contains that text box that I'm typing into. So the way it's supposed to work is as the user's typing, the changes are being updated into a local Hiro variable. And then when the user hits the save button, we're going to admit this Hiro object, and that's going to get added to the central data store. And the reason that this works correctly is that we have a defensive copy in here. So in ng-on changes, every time a new Hiro object comes down from the central data store and gets put on this component, we make a copy of it, and that copy is stored here in our variable. And the template is then updating that copy. So in our template, we have a simple ng model, which is updating hero.name. And again, this works because this Hiro is a copy of the one in the data store. It's not the actual one from the data store. And that's how we're able to cancel and go back without affecting our central data store. Now, this is, again, very easy to break. Okay. So all I have to do to break this is forget these few lines here. Okay. So if I comment that out, it will look like it's working. The code all compiles. But when I go to my app, and I try editing it, and I hit back, it's already been modified. So forgetting that one line of code with a ... now I've broken my app, and users are unintentionally modifying the actual data in the data store. And so that's really easy on a large application for one developer to make that mistake somewhere. And it's not necessarily easy to catch. There's no compile time issues. It looks like it's working. If I went in here and tested the save, the save works just fine. It's not doing what I think it's doing, but it works. Okay, so that's difficult to detect sometimes. So that's why we want to enforce immutability at compile time and runtime. So first, talking about compile time. So TypeScript does give us a few tools. We have the read-only property modifier. So we can tell TypeScript, okay, here the name property on the class is read-only. We're going to modify it when it's constructed, and then we should never allow assignments after that. There's also a read-only map type, which is the next line. And that's kind of a shortcut. So we're saying that everything in this object pretty much is read-only. Okay, it's kind of a shortcut way for doing the thing above. And then we also have a read-only array interface, which is really just the same as the normal array interface, but TypeScript has removed all of the methods that could result in modification. So it doesn't have the push method or the shift method or things like that. Okay, so I'm just going to show real quick how those work in TypeScript playgrounds. Okay, so here we go. Let me see if I can make that bigger. Okay, is that pretty good? Yeah, okay. Okay, so this is just the class example from TypeScript Playgrounds. We have a greeter class here. It's got one property, greeting. Okay, so I'm going to add a read-only modifier here, but I want you to pay close attention to the right side and see what changes. Okay, so you shouldn't have noticed any change on the right side because this is a compile time metadata only. In fact, if I actually remove this entire line, nothing changes on the right side. These property declarations and classes are for TypeScript only. They do not affect the output JavaScript. Okay. Oops. Sorry about that. There we go. Okay. So looking a little bit at what it does give us for compile time, if I go down here, so I have an instance of a greeter, and I say greeter.greeting equals foo. Okay, TypeScript complains. At least I've got that much. And you may be thinking, well, I always write in TypeScript, so I'm safe. But it's pretty easy to fool TypeScript. If we get into any sort of context where TypeScript doesn't know what this is or not in the compiler, oops. Okay. So I cast it to an any, and now it gets through the compiler, and now I have a runtime error. So if I run this, it says hello foo. Okay. Now, of course, you might be thinking, we're not going to go around casting things to any. That would be stupid. But when you pass stuff to an Angular template, like in our example, we have an input field using ngModel to update things. We're passing this object to ngModel, and ngModel doesn't care that our TypeScript class has a read-only modifier. Okay, so we're totally bypassing the compiler in that instance. Okay, and I have a couple examples just the other things here. Just get rid of this. Just to show kind of what the other things do. Here we have the read-only maps type. So we're defining a type called greeting, and we're saying that in our greeting, the text and ID properties are read-only. So on the second line, I'm really just creating an object literal, but TypeScript is treating those as read-only properties because I said that, okay, I'm going to treat this as a greeting type, and greeting is a read-only object. Yeah?
Is that a deep read-only? Like if text
No,
were... Okay.
It is not deep. Yeah, so, right, so if these were object references, this was some, sorry. Let's see. I don't know, I'm just making stuff up. Anyway, so say we have a car object, and this is a reference. properties on the car would still be mutable. So it's only at the top level here. So if you really want to create a deeply nested object structure, you're going to have to do the work of going through and setting read-only on the properties of each nested object as well. So it takes some work there. Get back to where
Is that true of the properties as well? Read-only
modifier? Yes.
As well,
yes,
too?
that is true as well. Yeah, it's only saying that this property, that property is an object, the things inside of it are always mutable. And again, if we look over at the right, there is nothing special happening in the JavaScript. It's just plain old JavaScript. This is just an object literal. You can modify it all you want, add properties, whatever. So, and then the last one is the read-only array. So I think these things are useful. We just have to keep in mind that there are ways in which we can get hurt by these things. So we're going to have to use this in addition to other things. So here's the read-only array. Oops, I deleted too much. Okay. So here I have a read-only array. So what I'm doing is I'm creating an array of greeting objects, and I'm telling TypeScript to treat it as a read-only array. So then on the next line, it doesn't recognize the method push. I get some context assistance here. I have all the typical array methods like filter and find and for each, but I don't have any methods that modify the array like push and shift. But again, over on the right side, all I've done is create an array, and now there's a push call. So there's nothing in the runtime. Okay. So moving on to runtime. Let's back to the slide here. Okay. So we want to have runtime immutability, which means that if somehow, say in an Angular template, something does try to set a property on an object, we want it to blow up. We don't want data to accidentally get modified. We want it to throw an error. We want to know about it so that we can catch it and fix it. Okay. So there's a few different ways to achieve real immutability. But I think the simplest way to do it is to go ahead and use a library called Immutable Jas. Okay, you can make things immutable using just plain old JavaScript, but it's not intuitive. Most people probably don't know how to do it. It's just going to be a lot easier to work with a library like Immutable Jas. And so Immutable Jas provides a great API for collections, so lists, sets, maps, things like that. So these are immutable collections. If you try to set a property on one of them, it's going to just return a new collection. So they have all the same modification methods that a traditional array or map would, but these methods then return a brand new brand new list or map. Okay. And Immutable Jas tries really hard to stay consistent with the plain JavaScript APIs. So if you look at the API for ES 2015 arrays or maps, it should be pretty similar to the APIs available on an Immutable Jas list or map. Again, the main difference is going to be methods like push return a new list, okay, or set returns a new map. And there's a few more convenience methods as well. So you have your ngrx application. You want to make everything truly immutable. You go through, you find all your arrays and your maps. You convert them over to Immutable Jas. That takes almost no time at all. Super easy and great. But then you're left with a bunch of JavaScript objects. And nobody really wants to go through and convert all of their objects to maps. You could, but that's not a very good API. So Immutable Jas does provide something called the Record API for creating immutable JavaScript objects that actually feel like JavaScript objects with a dot notation and work the same way you would expect a normal JavaScript object to work. Okay. So I'm going to bring up just a quick example here. There we go. Okay. So I just threw together a little example. Up at the top here, we are importing list, map, and record from Immutable. I'm not going to spend a lot of time on the collections because I think that's pretty straightforward. You use this list.of function. You can create an immutable list from various things. Here I'm just passing in some numbers. So I'm creating a list of numbers. And then as you can see on the next line, if I want to add something to my list, I call push. And then I need to assign it back to my variable because it's created a brand new list. And the same thing is true more or less of map. We have a map of, and I can pass in There's several constructors and of functions. It is overloaded. So I can pass in here, I'm passing in an object that contains properties, and those will become properties in my map. Okay. And then again, if I want to update a property, I just call set, and it returns a brand new map instance. I do want to point out how well this works with TypeScript. So these do have generic type parameters. So TypeScript knows that the things in this list are supposed to be numbers. I can't push something else. TypeScript will complain, so that's nice. So I haven't lost anything here. I've still got all my compile time checking, and I've got my runtime immutability. So it's great. Where things start to get less great is with the record object. Okay. So record is a little weird at first if you look at it. So record is actually a function. It's not a constructor. It's a function that returns a constructor. So you're kind of defining your own class dynamically. Okay, so what you're passing into the record function is an object literal, or you can find it somewhere else, but you're passing in an object, and the properties on that object will become the properties in your new class. Okay. If you don't put a property here, then it's not going to exist on your new class. Everything has to be listed here. And these values are going to be the default values. So again, you're creating a constructor, you're creating a class. And so every time you instantiate a new instance of this class, these are going to be your default values. Now, if you say, I don't want a default value, I don't care, I just want everything to be undefined, you have to explicitly do that. Okay? So if I want my name to be undefined, I have to explicitly say that. Because my object can only have properties that are explicitly listed here when I pass this object to the record function. Okay. So again, this returns a constructor. So here, Hiro is a constructor. And so I've uppercased it so that it looks like a class, like a type. Okay, so it is a constructor function. So now when I want to create a new Hiro object, I use the new operator, I say new Hiro, and then I can pass in the values to set those properties. So Hiro is going to be immutable, so I have to set any values in the constructor. And so I am passing in this object. And here I have a name, an ID. If I were to leave off one of these properties, then the ID for this Hiro would be 0, because that's the default value that I specified. If I come in here and I say something else, like foo, it will just get ignored. Okay. So unfortunately, this is where things start to fall apart with TypeScript. Because TypeScript thinks that's totally cool. But it doesn't make a lot of sense. It's going to be ignored. So this might represent an error in my code. It might not. But if I pass in foo, I'm going to create a new Hiro object. It's going to have a property name and a property ID. It will not have a property foo. It'll just get completely ignored by Immutable Jas. Okay. So now getting into the API. So we have a Hiro object called Magneto. So that's our instance. We can use get and set methods on it. So we can get the name property using a get method. And if we want to change a value, we're going to use the set method. And that is, again, going to return a new instance of a Hiro. Okay. Now, using get and set doesn't really feel like working with a regular JavaScript object. So you can use the dot notation. So if I come down to here for a second, you can just say magneto.name and get it back. That is valid JavaScript. It will work at runtime. Unfortunately, TypeScript doesn't realize that. So TypeScript thinks that Magneto is actually a map. It sees them all as maps of strings to any, basically. So you can't do this in TypeScript, even though it's perfectly legal at runtime. And going the other direction, let's see. Oh, yeah, here. This is another example of something that's illegal. This time, this is illegal for Immutable Jas, but TypeScript doesn't realize it's illegal. So what am I doing here? I'm actually trying to set a property foo on my Hiro, but Hiro doesn't have a property called foo. So Immutable Jas actually throws a runtime error for this line, but TypeScript didn't help me out. So Immutable Jas records are pretty cool, except for that we have this big disconnect between what TypeScript thinks it's doing and what Immutable Jas thinks it's doing. Ideally, we'd like to have both of those things working together. Okay. brings us to the record extension pattern. Now, I want to give credit. I didn't actually invent this myself. I found this on a blog post while searching the internet, and so I have the link here in the middle of the slide. And so it's a pretty good article. But basically taking what he did in that article and put it here, added a bit more TypeScript checking as well. And so we have something now that has all the compile time checking as well as all the runtime checking. And so I'm going to show you just by looking at our Tour of Heroes app. Okay. So first of all, let me get to the right version. So let's see. Okay. 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 So let me just. Okay, so on the right we have our original Hiro class. So a Hiro is, again, an object, a class that's going to be used in our central data store. So we want to make sure it's immutable. It is what's being passed to ngModel right now and is the source of our current bug. Okay, so we want to make it immutable for real. On the right, again, it's just a simple class with an ID and a name. So we're going to replace that with the code on the left. Okay. So looking at the bottom part here first, this is where things are going to start to get a little strange. Let me go ahead and close this one. There we go. Okay. So we're going to create a subclass of our constructor that we create by calling record. Okay. So this is how it would typically be written. I'm going to change it for a second just to make it a little more clear what's happening. So I could rewrite this way. Super. Okay, so if that syntax was throwing you off, this might feel a little more comfortable. Okay. So again, the record function is really just creating a constructor. And the way prototypal inheritance works in JavaScript, when you're extending something, you're really extending from the constructor. Okay, so in this extends clause here on Hiro, all we need is a constructor function. Okay, so we're creating our Hiro super. This here is following the traditional pattern for creating an Immutable Jas record class, and then we're extending it with Hiro here, just for the sake of adding TypeScript information. So the whole point of this is to get TypeScript to play along with us. So here in our Hiro class, we extend Hiro super, so we're getting all the same stuff we were before from Immutable Jas. But now we're adding these properties here and marking them as read-only. So these are the exact same properties that we've already specified to the record function. And again, remember that this is TypeScript compile time metadata only. It does not affect output JavaScript in any way. This is just here so that TypeScript kind of figures out what's going on. And so this will allow us to use the dot notation with our record object. And then in our constructor, we're just going to be calling super. So we're going to be passing our parameters to the Hiro super constructor. What we've done here is for the type that we're sending to the constructor is we've defined another interface. Again, this is just to help TypeScript along. So in our Hiro class, everything is read-only and it's not optional. In our Hiro param interface, we have all the same properties, but they're optional and they're not read-only. And this makes it easy for you to call the Hiro constructor with some or all of the properties that you want to set. So our constructor is going to take a Hiro param object and then use that to construct a new Hiro. The other thing we have here is an assign method. And again, this is really just here for TypeScript. So I am way over. Okay. The record classes have a bunch of methods to help you work with them. One of them is the merge method. So the merge method will take in an object containing new values put them onto the old object and create a new one. So whenever you need to set a property in your record, you can call merge, and it will create a new object with all the old properties plus any new ones, any new changes. And so we're wrapping this in a method called assign, mainly so that we can get some better type checking. So the problem is that the merge function returns a type of map, and we don't want to work with maps. So here we wrap it in our own function, and we do as this, so that TypeScript is going to treat the return value from this assign method as a Hiro object. Okay. So let's go to the reducer. Reducer. Okay. So we've followed the same pattern for everything in our central data store. Here we have the Hiro state class. It does the same thing. And so all these are going to have this assign method. So moving down to our reducer. So before we had that dot notation to create a new object. Here we're using that assign method to make it just a little simpler. So state is our Hiro state object. Again, it's really an Immutable Jas record, and it has this assign method. So I can pass in all or some of the properties from Hiro state and get back a brand new object. Okay. And so here I'm just changing selected Hiro. Here I'm changing the selected Hiro and the adding Hiro flag. Okay. And so this is going to have the same behavior as me doing the object literal with the dot, 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 or using object.assign, just a little simpler. Okay, so let's see here. Okay. Are there any questions about this so far? Okay, very quiet. All right, so we still have a bug in our application, but I want to show how it behaves differently now. Okay, now should I open up the console here? Okay, let's edit our Hiro. Oh, okay. So very unhappy. So I still have ng. I'm still passing my Hiro object to ngModel, and ngModel is still trying to update it. And now my application is having a major issue. But at least that's something I can catch. So I'd rather err on the side of not mutating state than accidentally mutating state. And here's something for me to find. So if I hit save now, I'll see, oh, that didn't work, and I can see in the console exactly why it didn't work. Okay. And again, the only reason we didn't get a compile time check for this is because this error is happening in the Angular template. If I go to my code in the Hiro detail view component, just to illustrate, I do get compile time errors if I do it in code. So if I try to do it in my Angular code, that will give it a compile time error. So I got compile time and runtime. Okay. So I need to fix my bug. So I'm going to go ahead and do that. Okay, so this is the template. That is the problem. I haven't actually changed much in here, so I'm still using ngModel. I know many people would argue that we shouldn't be using ngModel in the first place, but this is the original example, so I'm going to see how we can fix it still using ngModel. The only thing I've changed in the template is I renamed Hiro to Hiro edit. That was the only change. I just renamed my variable. All the changes are going to be in the code here. Okay. So now instead of passing that immutable Hiro directly to my template, whenever a Hiro object gets set as my input, I'm going to first store a private reference to it, and then I'm going to use this asMutable method. Again, this is from the record API from Immutable Jas, and it's going to go ahead and make an immutable copy for me, and I'm going to store that in the Hiro edit variable. So Hiro edit is now a mutable copy that I'm passing to ngModel, so ngModel can do whatever. Then when the user hits save, I'm going to go down here in my save method, and I'm going to use that assign method again on my real Hiro object, pass in my changes from Hiro edit, and it's going to create a brand new Hiro object, and that will be dispatched to the central store. Okay. Again, there are a lot of other solutions for this, like using reactive forms, things like that. This was a simple change that would make kind of the original example still work. Okay. Is there any questions? Okay. Oh, yeah. Go ahead.
I'm not quite following why we need a mutable Hiro edit. It does nothing.
Okay. This Hiro edit is being passed to this template, and because we're using banana in a box with ng model, every time I type into that box, the code behind ng model is setting the name property on Hiro edit. So if that's an immutable object, it keeps calling object.name equals as I'm typing. So it has to be a mutable object in there. Okay. A different solution would be to not use ng model and to kind of separate these things out and then do some sort of either ng model change handling or use reactive forms or something like that. But because the original example is passing it, is letting ng model both read and update it, we have to make sure what we hand to ng model is in fact mutable.
Gotcha. You just don't necessarily need the original version that's passed in.
Yeah,
So you're doing like a revert or something.
yeah. Let me go back to that because that's a little. Yeah. So in my example, I'm kind of saving off the original, and then I'm doing this using a sign. I probably don't really need to do that. I could. If I can do this. I think from this Hiro edit object, I could actually create a new Hiro object. Well, actually, yeah, I can do this for one thing. I could just do new Hiro. I could have done it this way. That would work just as well. It might be slightly more efficient to do the sign because Immutable Jas is only going to actually create a new object if things have changed. Really, it's probably about the same.
Assuming all your form values are on your object and you're not splitting one project.
This is true, yeah. Assuming that Hiro edit really is a full copy of everything. Yeah. Yeah, I mean, another way I could have done it is, I could have just, I'm not going to do the template, but, if I had like a name property here, and I was updating the name property with like an ng model change or something like that, and then here, I could do something like that, if I actually had an event handler, so as they typed in, have an on change, I'd be like, or set name, something like that. Okay, this stuff. Jeez. Okay. This is why I don't like it. Do something like. Actually, okay, so I've kind of gone off the rails here, but just talking about the name property. If I had a name property, I could do something like change, we'll set name. Is that right? Or is it just okay, something like that. Okay. Point is, there's a lot of different ways we could do this. At the end of the day, we have to make sure that whatever we pass to ng model is mutable, or that if we're not using ng model, we're somehow storing that intermediate property name. And then when we hit save, we need to be sending a brand new object with that new name value to the central data store through an action. Okay. As I feared, I'm more or less out of time and I haven't hit my second topic yet. We'll try to make this one quick. Okay. So moving on from immutability, talking real quick about the ngrx-enums library, which again was written by Mr. Lance Finney over here. So if you have any questions afterward, you can ask me or him. So generally, I think people like ngrx, like Redux. It's helped us out a lot. The big complaint usually is kind of how verbose the code is, how much boilerplate there is. And really that's only true when we're talking about type safety. If you look at the very basic ngrx example of creating an action, it's actually not that much code. It's just, you have a string, create an object, you're good. But if you really want type safety, and here we are, doing TypeScript, then you got to add a lot of extra stuff to achieve that. Also, in effects, it's a little bit difficult to achieve type safety, even with the recommended way of doing it. So we're going to see how we can use ngrx-enums to actually reduce the amount of code and improve the type safety. Okay, so first let's look at an example of what it is we don't like here. So get out of all this stuff for a second. Action. There we go. Okay, so this is hero.actions.ts. This is where I've defined all my actions. This is using the recommended pattern from the ngrx website for doing typed actions. So we've only got 14 actions, but we have in this file 137 lines of code to define 14 actions. And that's not even logic. That's just defining an action with a string type, right? And again, the reason it takes all of this is to get TypeScript to understand what we're trying to do. So the first thing we do up here is we define a bunch of string constants. And these are the unique identifiers for our actions. And then for each of those string constants, we now have a separate class definition. Okay. And each of these implement action, we each have a type property equal to one of those string constants. And if it's an action that takes a payload, then we have a constructor, and we're using that to, define the payload property, and also to tell TypeScript what the type of the payload is for this specific action. So again, there's really no business logic in here. We're just setting up these actions with string types and payloads. So once we get through all of those repetitive classes, then at the bottom we have this thing, which probably doesn't make a whole lot of sense to most people. This is where we're defining I believe it's called a discriminated union type in TypeScript. Okay, and this is so that later in our reducer, our switch statement will be able to figure out what action we're talking about and use that as a type guard. Okay, so here we have to take all of the action classes we defined above and OR them together to define a new type called actions. So again, that's 137 lines of code just to define our 14 actions in our system. And now if I open up my reducer, here we go. Okay. So here is our reducer. Now the reducer doesn't really have that too much boilerplate. It's not really that verbose. As far as amount of code, we can't really get much better than this. And then right now it is very type safe, but the way it achieves that is not really very intuitive. If we look at, first of all, let's look at the top here. So we're importing everything from that actions file as Hiro Actions. So that includes our classes, our string constants, and that discriminated type. So here in our reducer, the type of action is our discriminated union type. Okay, and then we're switching on the string in the actual action instance, pairing those to the string constants, and then magically, based on that, TypeScript will figure out that, let's see, for this one, which is set adding hero, it can figure out that the payload is actually supposed to be a Boolean and actually maps to set adding hero action. Now, to me, this is not at all intuitive. Okay, you have to look at this quite a few times to figure out how it actually works. All right. And again, it needed the 137 lines of code in the action file in order to make this work. The other thing is the effect. Okay. So looking at an effect that has a payload. There we go. Okay. So when you're dealing with an action that has a payload, the first 3 lines here generally look the same. If you're listening to action $, you're filtering on the action type, and this is going to be that string constant you're passing in. And then you're saying, okay, now give me the payload from that action. And here I'm telling TypeScript that, yeah, that's a save hero action, so it knows that the payload is a hero. But I can tell TypeScript anything at this point. So if I say this is a get hero action, it's totally cool with that. And now it thinks the payload is a number. So that's not very useful. Now, if you look at the docs for effects, it will tell you, well, you can put in a type here. So I can put save hero action type here. Okay. And now if I change this one to the wrong thing, okay, it complains. But, I could just as easily change this. And now it's still screwed up. Okay, but TypeScript is happy about these 2 lines. But this string constant doesn't actually match to this action class. So it's a potential for messing it up. And again, these first 3 lines are kind of boilerplate. Okay, so, sorry, I'm running out of time. Okay. So, ngrx-enums, again, is a library. It provides type-safe enums for your actions. Since we don't have much time, I'm not going to go into a lot of detail about what these enums are, but it's based on ts-enums, also written by Lance Finney, which is just a way to get Java-style enums in TypeScript. So if you're familiar with Java, a Java enum is really a class with a set number of immutable instances. So that's how we're going to model our actions. We're going to have a class representing all of our actions, and each action is going to be an instance of that class. At least that's how it would be in Java. ts-enums gets us as close as we could get to that with TypeScript. Also, the ngrx-enums library provides some methods on these enums that make it a little easier to remove some of the boilerplate. So just jumping straight to the example here. So I'm just going to go to the head of... No, it's not the head. Hold on. So if you go out on GitHub and look at this application, this is what you're going to see. This is the final version of it. So looking first at Hiro Actions. So remember, our previous file was 137 lines long. This file is only 37 lines long. So we lost 100 lines. We actually have 13 actions in this one. I moved one to another file. But this is what it's going to look like. So this is your standard pattern. Instead of having a class for each action, we're going to have one action class, and each action is going to be an instance of that class. Okay? So we have here a hero action. We're going to extend action enum value, and that again comes from ngrx-enums. And this type parameter you see here, this is the type of the payload. So we're using generic so that we don't have to create 14 different classes. Now we're going to group all these action instances together inside of an enum type. So ngrx-enums gives us the action enum superclass. The type parameter here is the type of our actual action value. So we have like the action enum and the action value. Okay. So going in here, these are all of the actions in our system. They're each defined with exactly one line. So that one line contains information for both what is the type of the payload. So a load hero success action has a list of heroes in the payload, and it provides the unique identifier for that action. So this is the type for that action. So we've now done that all in one line, and TypeScript knows all the information it needs to do type checking throughout. One more point down here in the constructor. We're calling this method called init-enum, which comes from ts-enums, and that's actually going to do a lot of housekeeping. It's going to take these objects we passed in and, take all these properties. It's going to freeze them, make them immutable. It's going to check for us that all of these type names are unique within our application. And it's going to check that this enum name down here is unique within our application. That means that you cannot construct this class twice. The second time you try to construct it, it will blow up. And in that way, it really does behave like a true enum. Okay. So down here, the last line, we have to construct it once. This is the only time it will be constructed, and then we're exporting that as an enum constant to the rest of our application. Okay, so let's just see how it's used real quick. Detail. There, okay. I did not expect it to do that. Okay. Jeez. There we go. Okay. So going down to dispatching actions. So now whenever we want to dispatch an action, we find our enum instance. So we have our Hiro action enum. Save Hiro is our action. And then we want to create an action object to dispatch. So we pass in our payload through the toAction method. And that's going to return back our actual action object to dispatch the central data store. And TypeScript does know that this toAction method is supposed to take a Hiro, and that this one is supposed to take a Boolean. So we have full typing here. And what it actually returns is typed action, which is just a simple interface that implements action. So basically we have a type of string, and we're identifying a payload and specifying what type that payload is. Okay, so last bit is, last two bits. The reducer, show it real quick. Okay. So the main change in our reducer, again, it's not less code, but I think it's a little easier to understand. Our type for action is now just typed action, which is pretty much a generic type for actions. We did have to replace the switch statement with an if-else just to get it to work, but it's not really any more code. So now we have, we're trying to match it to a specific action instance. So here, the reset blank Hiro is one of our actions. It has a matches method. So we pass in our action, and not only does it tell us, okay, this is a reset blank Hiro action, it also works as a type guard for TypeScript. Okay, so if we go down to one that actually has a payload, so set adding Hiro, TypeScript now knows that that payload is a Boolean. Okay, and it knows that this payload down here is a Hiro, because matches works as a type guard. Okay, and moving along to the effects, just because I'm out of time. There are a couple advantages in the effects as well. So here I have my save Hiro. So before those previous 3 lines of code that selected the action based on type and then mapped the payload, I've now replaced with this line here. So I say save Hiro.of, I pass in the action $, and it's going to subscribe to the actions observable, filter on actions of type save Hiro, and return the payload as a Hiro. So if I go down here, let's make this a little clearer. Oops. What did I do wrong?
You need your parens around it.
Oh, right. Sorry. Thank you. Okay. So just to illustrate that TypeScript is working here, here I'm saying this is a Hiro. Okay. If I try to say it's anything else, TypeScript immediately complains. So it's very safe. There's no way that I can have make a typo or have some disconnect between the type of action I'm filtering on and the type of payload that I'm getting. That's all handled in here in this of method very succinctly. Okay. So I'm going to stop it there since I'm so far beyond out of time. It's ridiculous. My last slide here is just a list of resources, which I think I stopped presenting. So I do have a list of resources, links to those blog posts I was talking about, and also links to Lance's talk and some of his GitHub repos. Okay. Any final questions? Okay. Hope you're all still awake enough to drive home. Thank you very much.